formulas that are true for sine and cosine, and also tangent. And what you're going to find out is that because of the cyclical nature of these functions, we get a lot of different things that are equal to each other, so things that we can substitute in place of other things. So let's say someday in the world you are asked to find the sine of two things being added together. Sometimes that's kind of tricky. Sometimes the thing that you get isn't something that's on the unit circle. And so what we need to do is break it apart into smaller pieces that are on the unit circle. And so that's what these formulas help us with. So if you come across the sine of something, like 11 pi over 12, is that on the unit circle? Is it? 11 pi over 12? No. There's no pi over 12, right? However, thank you. However, if I did 8 pi over 12 plus 3 pi over 12, do we agree that add up to 11?
Yeah.
And watch me reduce. So 4 goes in there twice. So this will be 2 pi over 3. Is that on the unit circle? Yes. This would reduce to 1 pi over 4. Is that on the unit circle? Yes. So the goal of today is kind of finagling things. So if you come across a problem that you can't do at first glance, you can break it into little bite-sized pieces that you can actually deal with, and then you can go from there. So that's what these formulas help us do. So let's take a look at cosine of 15 degrees. That's our first example. Is 15 degrees on the unit circle? No. So that's a bummer. Let's think of two things that we could either add or subtract to get us to 15. And those two things should both be on the unit circle. So I want to think of two things that I can either add or subtract to get to 15. Yeah, that's what I would use. Now, do you see that this could be a spot where you could pick different things? Does that make sense? Like you could pick different things, and that if you subtracted them, they would still give you 15 degrees. So it doesn't matter if you pick the same thing I do. It's forgiving in that way that the formula works for everything, and that this is something that you can use for whatever numbers you choose. So do you have to read my mind and choose the same ones? No, you'll be fine. All right. So now let's think about this in terms of our equation. And again, the equations are going to be given to you. So if I have the cosine of s minus t, I'm using this one, agree? So the first thing is my s. The second thing is my t. So I'm going to label those within my equation as s and t because that helps me make sure that I put in the right stuff in the right spots. Okay, let's plug stuff in. It is equal to the cosine of s, so the cosine of 40 degrees, times the cosine of t, so the cosine of 30 degrees, plus the sine of s times the sine of t. Ooh, you can't see that. Oh, God, I'm afraid to zoom out, you guys. Oh, I did it. Okay, so do you see how I just plugged everything in? I subbed in for s, I subbed in for t. Again, you don't have to worry about memorizing the formulas. I can't stress that enough because I feel like that's the tricky part. Okay, what do we know the cosine of 45 degrees is? Root 2 over 2. So I can evaluate and replace that with root 2 over 2. That's like a substitution move, right? I know what cosine of 45 degrees is. So I'm going to put that in place of it. Cosine of 30 degrees. Remember, you can always draw yourself a little picture. So 30 degrees, I'm over more than I am up. So this is going to be my root 3 over 2 for x. And then my y there is 1/2. What's my sine at 45 degrees? Root 2 over 2. And then my sine at 30 degrees, 1/2. Okay, so we are going to simplify this down. So we're going to keep going a little ways here. Root 2 times root 3 is going to give me root 6 over 4 plus root 2 over 4. And then I can't actually add those roots together because they're not like terms. One has a 6, one has a 2. But I can condense it down into a single fraction because they have a common denominator. So this would be my final answer. And again, I always think, and I know I've used this as an example before, but I always think of the movie Elf when I do these problems. Remember when Buddy the Elf sees, when he hears Santa coming, and he's like, Santa, I know him. That's how I feel about stuff that's on the unit circle. I know the sign of 35, or not 35, 30, or 45. I don't know 15. So that's what it reminds me of. You have to do stuff that you know. All right. Let's pretend we're Buddy the Elf. Do we know him? Is he on our unit circle? Is that on our unit circle? No. So let's think of some things that we actually do know that are on the unit circle. This time I'm going to go addition. What are two things that I could add together to get 7 where they would reduce into nice things that are on my unit circle? This is the tricky part. 3 and 4. Let's try 3 and 4. And again, worst case scenario, you try something and it doesn't reduce to something on your unit circle and you're like, oh, bummer. And then you try again. All right, so this is going to be the tangent of, this one will reduce to pi over 4, plus this one will reduce to pi over 3. Do you agree if I add those two back together, I should get back to here? But this is like the Buddy the Elf moment. It's Santa, I know him. Do we know the values at these points? Yes. So that's why this is beneficial to us. Now, if you are feeling like a rebel today, could you have these flipped and it would be okay? Yes. So those could be flipped. Again, the formula is forgiving that as long as your values add up to 7 pi over 12, they don't have to match mine exactly. Okay, this equation's a little bit more involved. Here we go. This is my S. This is my T. So it's always alphabetical order. S is first, T is second. So we want to use the plus. So I'm going to go tangent of S. So the tangent of pi over 4 minus the tangent of T. So the tangent of pi over 3 all over 1 minus. I'm plugging into this formula. So I have addition. So I take the tangent of S plus the tangent of T all over, oh, it's not subtracted, it's plus on the top, thank you. All over, the bottom subtracted. Tangent of S times the tangent of T. All right. Before I go any further, I'm going to make sure I know what the tangent of pi over 4 and the tangent of pi over 3 is. So the tangent of pi over 4, remember, is sine over cosine. My sine and cosine are the same thing though, aren't they? So root 2 over 2 divided by root 2 over 2, what's my tangent? 1. So those are kind of nice. Those always work out to be 1 or negative 1. So I love seeing a 4 in the denominator. Okay, the other one, not so much. So if I'm at pi over 3, that's the same as 60 degrees. And so if you take your sine over your cosine, it should give you root 3. So this location, sine divided by cosine is 1. This location, sine divided by cosine is root 3. All right, so now let's start plugging stuff in. So in place of tangent of pi over 4, I can put in 1. In place of tangent of pi over 3, I can put in root 3. All over 1 minus So in the denominator, we've got these two things being multiplied together, so it's all over 1 minus root 3. Now, on a good day, we might be done, but what am I going to tell you have to do? Yeah, you have to rationalize the denominator. We can't leave a root in the denominator. How can I do that when I have two terms? Do we remember? The conjugate. Oh, you remember the name too? I love that. That's not usually one people remember. Good work. So I'm going to multiply top and bottom by the conjugate. Remember, the conjugate is just a fancy name for taking what you had and switching the sign, because that's going to help the terms with the roots cancel out. Oh, sorry. All right. Well, people watching the video are going to be scared because they won't see that sneeze coming. Okay. It's going to be a scary video. All right. 1 times 1 is 1. This is going to give me 1 root 3 plus 1 root 3. So I'm going to get plus 2 root 3s. Root 3 times root 3 is root 9. Well, what's the square root of 9? 3. Okay. So that's the top. In the bottom, remember, you only need to fold. You don't need to use your vowels because those are going to cancel each other out. I mean, you can, but you don't have to. 1 times 1 is 1. A negative times a positive is a negative. Root 3 times root 3 is 3. Okay, let's keep simplifying. I can add the 1 and the 3 in the top, so I have 4 plus 2 root 3 all over negative 2. Oh, I get to have some more fun. What do I get to do still? Divide by 2. Negative 2 minus root 3. So if I divide each part by negative 2, 4 divided by negative 2 is negative 2. 2 divided by negative 2 is negative 1. So I divided everything through by my negative 2 to get that nice in quotes. Nice answer. Okay, let's try one more. So I'm going to have you guys try it. It's almost the same thing, right? We have the sign of 11 pi over... Oh, I already gave you this one, didn't I? Okay. So you know how to get to 11 pi over 12. You try it. I'm going to pause. All right, here's my answer. Take a look and see how you did. If you got it wrong, see what you did wrong. If you had maybe them flipped, like you had 3 pi over 12 plus 8 pi over 12, that's fine. You should still come out to the same answer. Now, listen. Here's something you're going to notice when you do the problems tomorrow. Like I said, no homework tonight, but tomorrow, because there are only so many different spots on my unit circle, are we going to see some of the same suspects over and over and over again? Yeah. So we're going to see some of the same numbers repeatedly. So just, if you're like, I feel like I've had this answer before, you probably have. Because there are only so many different things we can do on the unit circle.